Good afternoon, at least where I am. Just trying to get back out of here. Like I said, UT3, we're going to take a little bit more practical approach to the labs. What you should have in front of you as you're doing this is your lab packet with labs 1 through, let's just say 10. Well, looks like about 13 actually. Okay, so labs 1 through 13. What I'm going to do is just start off with lab number 1, start working it, and then I'm going to work it, and then I'm going to show you what I did, and then I'm going to ask you a question about lab 1, then I'm going to move on to lab 2, lab 3, so on and so forth, and I'm just going to continue to ask you questions about each lab as we travel through. So what we're messing with here, to start with, let's back up a little bit so you can see, is just the IIW block. Okay, there's the IIW block laying right in front of the scope, and then there's the scope right there. We're just using the GE Inspection Technologies Phaser XS. Okay, if we zoom in a little bit here, should be able to see pretty much what we have going on. We have a 7-inch range, or roughly a 7-inch range, 0 probe delay, and then a little bit of display delay. I'm going to take that all back to 0. Okay, we're messing with steel, mild steel, so I'm going to take this back to 2300 or 230,000 inches per second. And I'm just going to go to a 4-inch range just for fun so I can get started and see where I'm at here. So 4-inch range. Okay, 0, 100%, that represents 4 inches. So, let's back out. You can see what I'm actually doing here. That ought to be about good. You can see the top of the screen anyway. Transducer, just a regular 2.25 megahertz. So I'm going to go over here, set my pulsar receiver. Okay, what signal you like the best, or what signal I like the best in this case. Not really making us a huge difference right there. Okay, I'm going to match it to the scope. Alright, so you see right there, let's zoom in a little bit. If I pull the transducer off, you see the end of the near field ring down coming off that transducer, and then you see my signals come up there. Well, my signals aren't exactly where they need to be, but that's not the problem. The bigger problem is we're actually getting a near field that stretches out to about 1 inch. So our first signal really is no good. It's useless to us. So that's all this stuff is showing us repeats of that same information, which we don't necessarily want. We just want information from our back walls. So we're going to bring our gain down quite a bit. That'll clean it up a ways. So I'm going to go back to range. Okay, I push the range button. Let's back out a little bit so you can see the buttons I'm pushing. So there's our range button. Lab 1 says to establish a 10-inch range. Okay, we're on a 4-inch range. So we just need to take our range to 10 inches. Alright, so now we should have a signal at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means each one of these screen divisions, let's zoom back in a little bit. Each one of these screen divisions, 1 inch, 2 inch, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So if we're on a 10-inch screen range, you can see my transducers down on the IIW block. Back up a little bit so you can see that. That's just how it's setting. If I pull the transducer up, let it refocus there, signals are all gone. Okay? So plug that guy down on there, and now I've got my signals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're not perfectly lined up. So I want to line them up a little better. I'm going to do that by fine range, or in this case, velocity. Okay, so we're close. We're not necessarily perfect. I'm going to push this over just a little bit. Okay, I'm going to come back to my velocity. Put them about right there. They're not always perfect, but they're pretty close. Got a little cold, so excuse me. Zoom back in. Okay, so we'll call that good for now, although it's not as pretty as it could be. For some reason I'm just not liking that. So there we go, that's better. So let's take our velocity back out a little bit. There we go. That's a little better. Okay, so there we are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all the way across. Alright. Let's give it a little more gain so you can see that 10th signal over there. All this is trash. Okay, there's 5, 6, 7, 8, 9, 10's right there. So your question for this lab would be, if that's a 10-inch range, how thick is this right here? Okay? Remember, this is a 10-inch range. So let me back out so you can see where we're at. We're just on the side of the IIW block, shooting this way. Okay, so that's a specific thickness. And according to the ultrasonic scope, how thick is that piece? Now remember, each one of those screen divisions represents 1 inch. Okay, so that'd be your first inch right there. That should give it away. Give you a second to look at that. Alright, so you should have it now. So anyway, first lab done, just testing a 10-inch range. We just set up a 10-inch range to make sure that our screen was calibrated, which it is. We know that the block's 1 inch thick. We had our 10 divisions across the screen, so that should make it a little bit easier.